Welcome to the continuing lecture in basics of machining. In this lecture, we will primarily focus on a machine tool, which is lathe. So, in this lecture, I will go in depth and try to explain to you on the machine tool side for a single point cutting tool. And this idea you can extrapolate when we try to do multi-point cutting or abrasive cutting. So, in the content of the lecture, we will have an introduction, followed by it we will have basic functions of lathe machines. And when we talk about a machine, the machine will have several subsystems. So, we will try to look into each of the subsystem like headstock, tailstock, chuck, bed, saddle, etc. Then we will try to look at various types of lathe machines which has got evolved over a period of time, and then some of very simple operations which we generally try to do with lathe machine, and finally, we will try to have a recap of this entire lecture. So, lathe machine, it is one of the most versatile and widely used machine tool in manufacturing industry. If you go to any industry, the first thing they will try to buy, or when they try to discuss, they will always try to take a lathe machine. I can say this was a basic machine. From here several other machines got spun out, right. So, if you see a typical lathe machine, you will try to have motor, this motor. So, here you will have a motor. This motor will try to give the RPM. So, now you have to control or restrict the RPM. So, you will have a gearbox. Now, this gearbox will try to maintain the speed which will be attached to a spindle. So, in this spindle you load your workpiece. If you see the entire story, it is here. So, you have a motor which is here, then you have a gear lever. So, here there is a gearbox where you will have combination of gears. Based upon the combination, you can try to have geometric progression in getting the speeds here. So, you have a gearbox. So, this gearbox is attached to a head stock, right. In the head stock, you will try to have a chuck. In the chuck, you try to load the workpiece. So, this is one part of the story. The other part of the story is, suppose I have a long lengthier workpiece, then there is a possibility when it rotates, it can wobble or it can deflect, it can go up and down like this. In order to avoid it, I hold the other end of the workpiece. There comes the tail stock. The tail stock will be used to hold the workpiece when you have a long lengthy one. So, tail stock, you will have a tip which tries to get advanced by rotating the handle. There will be a rack and pinion, or there can be a gear which tries to mesh. So, you try to advance the tail stock, it will go forward and it will try to lock. Right. The next important system is going to be the tool attached system. The tool attached system is the place where the tool is held. The tool, we saw in the previous lecture, the tool has a shank and a cutting edge. So, the shank is used for holding the tool. The tool can be advanced through rotating the handle here. You can orient the tool at any direction of your choice, such that you can try to make a horizontal flat or a tapered thing with respect to the axis, depending upon their movement. So, you have two rods here. One is called as the feed shaft, the other one is called as the lead screw. So when we wanted to operate in automatic mode, we will try to use the feed shaft, and we also try to have the lead screw to get the combination wherein which we try to control the feed rates. So this talks about this length motion, and you also try to have a freedom in this motion. So you rotate this handle to get the in the x direction you want to have, you will have like this. In the y direction, if you want to have, you can have like this, right. So you have this motion by the feed rod, lead screw. They both have independent roles. So they are used to move the tool post. The tool post is sitting in the saddle. So the saddle towards the spindle, right. So now let us see the names, whatever is given. Motor lever, then you have gearbox, headstock, wherein which you have a chuck. The chuck holds the workpiece. Now between the tool and the workpiece, there is going to be metal contact or metal polymer contact or metal ceramic contact. There is going to be friction, there is going to be a rise in temperature. So in order to avoid that rise in temperature, we use a coolant at the machining zone. So there is a coolant supply pump. So as I told you earlier, this is a tool post. Here in this machine, you have only single tool. You can also have multiple tools. For example, you can have a tool post which has a cuboidal structure, wherein which you can try to mount 4 tools. If you have a hexagon, you can try to have 6 tools. You can try to have, if you have an octagon, 8 tools. So all the tools will be loaded and it will be kept on the tool post. The tool post sits on a saddle. So this is the saddle. This is a saddle. So tool post sits in a saddle. So the saddle is operated by the saddle handle. The cross slide, which I told you, to move the tool in and out, is given by the cross slide, right. Then we have to understand about lead screw and feed shaft. The feed shaft, or they call it as feed rod. Then we have the tailstock. So by now you will be able to understand what are all the parts which are there in a lathe machine, and there are some functions you can guess. It works by rotating. This lathe machine rotates the workpiece held in a chuck or between centers. What are the centers? Headstock and tailstock, between the centers, right. While a cutting tool moves along the material to remove the excess material and create a desired shape. The cutting tool can move in this direction or perpendicular to the feed direction. It can go like this or it can go like this, or you can have combination of this, then you get a taper. The lathe's ability is to execute a wide variety of operation, from simple shaping to a complex machining task. If you can do the control of both the axes manually, you can try to make complex surfaces. Suppose you have to mass produce it, then this tailstock, the tool post, can be attached to a copy point or an engraving tool, which copies over the profile, and that is communicated to the tool post. So correspondingly, you try to get the shape on the workpiece. The lathe's ability is to execute a wide variety of operation, from simple shaping to complex shaping, makes it an essential tool in manufacturing. Lathe machine, if you have an axis symmetry part, if you want to do any geometry change, lathe machine is the fundamental machine which is used for. So whatever we have discussed, I have put in a very detailed fashion. Spindle, then I said there is a tool post, then there is the tool post is resting on a compound slide. So this is again resting on a cross slide. So this cross slide is sitting on a saddle. So this is called as a saddle. They call it as a carriage, right. Then I have talked about tailstock, the dead center, the live center. So the entire thing sits on a bed. Right. So when you wanted to have a automatic motion, then we try to use the engaging and disengaging. We also try to use a clutch for engaging and disengaging. So, this is the feed rod and this is the lead screw. They are used for automatic motion. So, in this machine we have an apron which is also there. The tool, once it machines, the chip falls down and it is collected in the tray, chip selection tray. So, some of the functions: material removal, use a cutting tool to remove the material from the workpiece. Shaping and sizing, creates cylindrical, conical and complex shapes. It can create shape and size. Thread cutting is also possible. Thread cutting we will try to see more in detail when we try to see when do we engage the feed rod and the lead screw. Right. So, it produces both internal and external screw threads. Drilling and boring is possible. Super finishing enhances the texture and accuracy of the workpiece. And where are these lathe machine used? They are exhaustively used in automotive applications, in aerospace, medical and military applications. Wherever you want to develop a precision axisymmetry part, it is possible. So, let us look part by part in little more detail. Head stock, right? You see there are gear trains. So, the drive is given to this gear and then subsequently you try to transfer the motion from this gear to the meshing gears. If the gear size is smaller, you will have higher speeds. If it is larger, you will have lower speeds. And if it is larger, the torque will be very high. So, torque is basically used when you give a larger depth of cut, we use a high torque. Right. The headstock is usually located at on the left side of the lathe and is equipped with gears. It can also have splines, chucks, gear speed control levers and feed controls. So, it is mounted in a fixed position on the inner vase, usually at the left hand side. Using a chuck, it rotates the work. So, that is where this gear train is attached to the spindle. The device called a dog is attached to the outside of the work and is used to drive the rotation from the spindle. So, there are two types of workpiece loading. One type of workpiece loading is you directly mount it on the spindle. The other way what you do is you try to have spindle, then you try to attach a face plate. So, in the face plate, when you look at the side view, you will have a slot like this. So, this slot, what will happen is you will try to in this slot you will try to attach it with a dog. So, this is called as a dog. So, dog, what it will do is it will try to hold the workpiece and it will try to lock it with the face plate. So, here the workpiece is not mounted to the spindle, it is attached to the device called as dog. So, it is something like this, the dog is placed. So, now when it rotates. Now, the dog in turn is attached to the workpiece. So, between centers, if you want to machine end to end, so then we use this. The device called dog is attached to the outside of the work and is used to drive the rotation of the spindle. Tailstock is the other end, which we already saw. There is a handle which rotates and then there is a rack. When you move, this tries to advance the tailstock, right? The tip. Okay. It is sometimes called a loose headstock or a pellet head, usually located on the right hand side. Left hand side is headstock, right hand side is the tailstock. The workpiece is supported at the end. The tailstock center has a conical tip. Why does it have a conical tip? It will have a conical tip. This tip is hardened and this tries to locate the workpiece. So, this is the workpiece. So, the tailstock center has a conical tip point which is inserted into a taper hole at the end of the workpiece. So, that it is a friction contact and it tries to hold it. The live center rotates in the bearing in the The tailstock center is either called a live center or a dead center. Live center means where you give rotation. Dead center means you don't give rotation. The live center rotates in a bearing in the tailstock so that there is a no relative rotation between the workpiece and the live center. A dead center is fixed to the tailstock so that it does not rotate. Instead, the workpiece rotates about itself. So, you have to understand the difference between live center and dead center in tailstock. So, these are all things which you can fix removing this conical part. So, you can remove this conical part and fix these chucks. So, here we will try to see the chuck. So, in a lathe machine, it is very interesting to see we have 3 jaws, and these 3 jaw chucks are called as self-centering chuck. So, that means to say when I keep the workpiece in between the 3 jaws and rotate one jaw, all the jaws will move uniform and help in locking the workpiece. It is interesting, when you lock one, all the 3 will come and you will it will grip the workpiece. It allows the mounting of difficult workpiece that are not round, square or even triangle. So, chuck, the 3 jaw chuck what we are trying to talk about is predominantly used for loading the cylindrical part. Moment you have square or a triangle non-symmetry part, then what happens, you will try to use a 4 jaw chuck. So, 4 jaw chuck is not self-centering chuck. Okay. So, it holds the device. The chuck are of 2 types. One is called as 3 jaw, 4 jaw. 3 jaw chuck is called as self-centering because when you try to rotate one of the jaw, this rotates the basic gear where on the face there are teeth, right. So, when you rotate this rotates. When this rotates, it tries to rotate every jaw. Okay. And here you put a key and then you rotate. So, this is 3 jaw chuck. It is very interesting phenomena, you should know it. So, 3 jaw chuck and 4 jaw chuck. The mounting the workpiece between the center uses a dog. So, this is called as a dog. So, which I was trying to explain. So, dog clamps the workpiece. So, this is the dog, right. This is a dog plate. Right. The workpiece is loaded and here you have the dead center which comes in contact. The conical tip is touching the workpiece, right. So, this is dog plate which is used for mounting the workpiece. So, the next one is a 3 jaw chuck wherein which the self-centering is done. You can also have a collet with three slits which is also used to mount the workpiece. So, this is dog, this is collet. Collet is when you try to expand, you can push it from one side. It will have a reverse taper. So, it will try to hold it. Then you can try to have a face plate for non-cylindrical part. So, this is 4 jaw chuck. This is 3 jaw chuck. This is 3 jaw. This is 4 jaw. Right. This is 3 jaw. This is with dog and this is with collet. Okay. Collet will have something like an inverse taper and here the slits are made and the tool is stuck and when you pull it, it gets locked. So, it is very interesting. You should see all those things. There are videos. So, I would encourage you to look at videos to understand more in details. So, next comes the important component bed. We have not discussed till now about the bed. So, this is the head stock. This is the tail stock, and till now we have discussed about the chuck. Now, all these fellows have to rest on something. The resting part is called as the bed. The main part of a lathe are usually made of cast iron. This is bed. Right. Provides a heavy rigid frame on which all the main components are mounted. All the parts are finally bolted to the bed. It includes headstock, tailstock, carriage, which is this is the carriage, and the lead screw feed rod, etc., etc. It also consists of lead screw, feed rod and rack and pinion on the bedway. So, rack and pinion is, this is attached to the carriage. So, you have a rack which moves on, you rotate it, there is a rack which tries to help you in moving. The size of the lathe is designated by the swing diameter. We always talk about the swing diameter of the chuck. The size of the lathe is designated by the swing and the maximum distance between the headstock to the tailstock, between the centers. Right. So, these two are used for specifying a lathe, the length between the two centers and the swinging diameter. They are basic. Apart from that, you talk about the motor rating and other things. Next important thing is the gearbox. Where is the gearbox coming? Motor is attached to a gearbox. This gearbox in turn is attached to a spindle. Why? You try to change the RPM, you try to change the torque. So, speed is changed and the torque is changed. So, when you want to give a higher depth of cut, you need a higher torque, right. So, correspondingly what we do is we try to reduce the speed. So, the gearbox inside the headstock offers multiple speeds with a geometric ratio by moving the lever. So, what we are talking about is geometric progression. So, why is it important? Can I get speeds from 1 to 100 RPM continuous? No, not possible. You will get maybe 1, then 5, then 23, then 64, something like that. So, what is this? This is geometric progression. These numbers do not match, but I am just giving you these jumps are there. So, this means there is a geometric progression, and this geometric progression comes from the combination of gears placed in the gearbox. The carriage, right. So, the carriage is the place where the tool post is mounted. The carriage is located between the headstock and the tailstock. This is the tailstock, right. It contains an apron, a saddle, a compound rest, a cross slide which moves and a tool post. As we saw, tool post is a place where we post the tool. So, then cross slide is this action. So, moves on the outer way, used for mounting and moving the tool post for the cutting tool. This is done by the carriage. The next two important parts are going to be feed rod and lead screw. Lead screw is used to move the carriage automatically during threading. The feed rod is used to connect the feed box and the slide box and transmit the speed and power to the feed box to the slide box, so that the slide box achieves longitudinal linear motion. So, this is lead screw and this is feed rod, and this is what is the rack which I was trying to tell you. So, when we have a rack, so you have a rack and pinion, this is a rack. So, the carriage will be mounted to a pinion. So, when you rotate the handle, it will get meshed with the rack and then it will try to move forward. So, this is the place where carriage is sitting and then carriage handle comes into existence. So, this is a rack, a feed rack, and this is a lead screw and this is the feed rod. So, lead screw is used for threading, feed rod is used for automatic machining. There is a chip pan, as I told you, it is at the bottom. So, where all the chip from the machining, it falls down, it goes to chip pan. So, then the chip pan is removed, we remove the chip. It is present at the bottom of the lathe. The chip pan is used to collect the chip that can be produced during the lathe operation. A hand wheel which is there, it is a wheel that is operated by hand to move the cross slide. To move the cross slide, carriage and tailstock and other parts with the hand wheel. So, hand wheel is very important because when you rotate it, this in turn tries to give you a linear motion. Then cooling device, a cooling device primarily is used for cooling, is used as a cooling water pump. It tries to supply cutting fluid at the location. This cutting fluid, whatever is supplied here, is used for washing the chip, lowering the temperature, and also trying to do lubrication to reduce the friction between the tool and the workpiece. It smoothens the surface and improves the tool life and service condition. Then you have slide box. Right? It is the control box for the feed movement of the lathe. It is furnished with a mechanism that turns the rotary motion of the light rod and the lead screw to the linear motion of the tool post. So, there are two things which we are talking about. So, slide box. So, this is the slide box, the carriage is there. So, now you rotate the handle. So, this is guided by there is a feed rod and a lead screw. So, this is used, the slide box is used. It is the control box for the feed movement of the lathe. So, what is feed? The rate at which the tool moves when it comes in contact or while it is machining. So, this is called as a feed rate. So, this can be generally written in mm per minute or mm per revolution. So, what is the advancement you get in 1 minute? So, feed movement of the lathe. When we talk about these two are feed rates, when we talk about feed movement, it is only millimeter. This is feed rate. Okay. This is feed. It is furnished with a mechanism that turns the rotary motion of a light rod and the lead screw to the linear motion of the tool post. This is a tool post. Cross slide. As I told you, cross slide is moving perpendicular, cross, mounted on the carriage. This is the cross slide handle. This is the top. You have the tool. This is a tool. This is the workpiece, and this is a chuck. So, the tool is moving in this direction. So, that is because of the cross slide, whatever is there. Mounted on the carriage, the cross slide moves perpendicular to the bed. This is a carriage. Okay. This is a carriage. This compound provides movement towards or away from the workpiece, crucial for the depth control of the cutting operation. It allows for precise adjustment in the position of the cutting tool. So, that means to say you have, when you rotate one round in a handle, right. So, this is 360 degrees. When you rotate, it can advance by 5 millimeter. So, now you can try to figure out for 1 degree what will be the advancement. It will be 1 by 360 into 5 for 1 degree. So, now this handle is divided into several segments. So, this is 30 degrees. Now, if you see this when I wanted to, this is for 1 degree I can find out. Then if I want to do for 30 degrees, I will multiply it by 30, and now I can divide the 5 millimeter into several small things. For example, one rotation is 5 millimeter, half the rotation is 2.5 millimeter, quarter of it is going to be 1.25 millimeter. Quarter is what? So, half is 180 degrees, quarter is 90 degrees. Now, I am going to do quarter is 1.25 millimeter. Now, I am going to go half of it, that is 45, that is nothing but 0.625 millimeter. Now, I am going to go half of it. So, that is going to be 0.16 something millimeter. So, now you see how precisely in the linear motion you get when you try to rotate it. So, spindle, a hole through the headstock to which bar stock can be fed. So, generally it will be a hollow shaft. A spindle is there, the three jaws come, and when three jaws meet also you will have a small gap in the center. So, now through which you can feed the rod. So, that is what is told as the a hole through the headstock to which bar stock can be fed. For example, you continuously feed a bar. So, then once a certain amount is done, it will truncate, it will make a bolt or a nut or a screw can be fed, allows the shaft that are up to 2 times the length between the lathe center to be worked on one end at a time. Right. So, this is called the spindle. The spindle is a hollow spindle. When I say hollow, there can be material coming from here. Here you will have a spindle. So, this center portion, this is a bar stock. When you want to do continuous operation, for example, bolts you want to make, then we use this bar stock. Nuts, bar stock, right. So, guideway is a place where the cross slide sits on it and it is guided, so that there is no deviation. To ensure the accurate movement of the tailstock and the carriage on the bed comes in and out of the way is done by the guideway. Then tool post we have discussed enough. So, here this is a single tool post, and here you can see 1, you can place it here, 2, then 3 and 4. So, there are 4 tools which can be kept on a tool post. Mounted, this tool post is mounted on the carriage, the tool post holds the cutting tool. It allows the tool to be positioned and secured at various angles. So, you can try to rotate it. So, it can be in 0, it can be in 90 degrees, it can be in 45 degrees, it can be in 30 degrees, it can be any of those angles. Right. Mounted on the carriage, the tool post holds the cutting tool. It allows the tool to be positioned and secured at various angles, providing the flexibility to form a range of cutting operation. The tool post is an adjustable part on the lathe machine. Compound rest. Compound rest sits atop of the cross slide and allows for angled cuts and fine tool posts and fine tool adjustments. It is used for precise cutting angle and finishing work. Provides the ability to make a precise angular cut and adjustment of complex machining tasks. Tool turret. So, if there is a restriction for 4, then you can always have a turret. In modern day CNC machine, they have a tool turret where you can load up to 564 tools in one shot. It is loaded, and only one tool will come for engagement for machining. The turret provides the ability to change the cutting tool as required. So, this is the turret. The number and the size of the cutting tool will determine the turret size. The CNC lathe machine, you have automatically calling the turret and then the tool is picked and placed for machining. Apron. Apron is a part of the carriage that houses the control mechanism. It contains gears, clutches and levers which is used for movement of the carriage and the slide automatically. The apron is essential for the operator to control and adjust the carriage position and motion during the machining operation. So, this is apron. So, here are the references which are being used for preparing the slides. Thank you.